Hello, so today we are going to do this problem, which is part of Leetcode daily challenge, smallest string starting from leaf. So we have a binary tree where each node has a value between 0 and 25, and those values represent the letters from A to Z. And what we want to do is return the lexicographically smallest string that starts from the leaf and ends at the root. So it's sort of bottom up. You go from the leaf and you go all the way to the root. And we want to return the smallest string we can get. So for example here, the different strings we can get from the leaves to the root are dba, eba, dca, eca, and the smallest one is dba. Okay, and so we want to return that. So that's the idea. Now, if you look, the node values are themselves are just letters from A to Z, and the nodes are not too many. So we can do some sort of DFS, an oven solution. And the way to do DFS here, the easiest way if you want to, is to start with a constant on the class, but we are going to do one that is a little bit different where we just return the result. But in terms of the structure, well, what we want to do is minimize the smallest, get the smallest string. And so each time we can just take the min. Let's just start writing out the skeleton of the DFS, and from there it will become clear. So for our DFS, we'll just do a node, but we also need to keep track of the string that we'll need to return at the end, right? And so let's call it so far, or let's call it current. Okay, now if there is no node, we should just return empty string because there is nothing. Now if it's a leaf node, so which means it doesn't have any children, so this is a leaf node, what should we do? We need to do something here. And then with DFS, usually you need to recurse on the left side and recurse on the right side, okay? And then you need to return something, right? And of course, we need to call it with the root and with what we have so far, right? Okay, so now let's figure out what we need to pass for each call on the left side and each call on the right side. Now, the values are numbers, and we need to convert them to letters. So to do that, let's call it just C. You need to do just the character for the number, which is in the value of the node, plus the ord of A. This is just a way to convert it back to a character in the range A to Z. Okay, so once we have the character here, we know that this is going to be leaf to root, right? The string is constructed leaf to root, so it needs to be dba. But our DFS is from root to leaf. So we need to, when we are concatenating, we need to add the character first and then add the current. Because remember, the order is going to be root to leaf. This is the order of traversal. But the order of the string, we need it to be leaf. We need it to be leaf and then root. Okay. So that's why we add the current character. So the last one we traverse would be the leaf one. So we add it first so that we get this structure, okay? We need to do the same thing for here. Now here we will need to return something. What should that be? Well, in the same way, it should be something like this, okay? And the current is just what we have so far that we pass as a parameter. Okay, now what should we return? Well, we know between two branches, what we want to do is get the minimum and return that to the parent. So for example, let's say BA, BE, the minimum is BD. That's what we want to return to the parent. And so what we want to do here is return the min of the two. Okay. Now we have a slight problem. What if this one there is no node on the left side? Like for example, let's see if we have an example like here. like here where there is no node on the left side, or here where there is no node on the right side. If we just leave it like this, where it returns an empty string, well, empty string is going to be smaller. So we need to just handle that case separately. So what if there is no left node, and what if there is no right node? We can't take the min, because then we'll just have the empty string as a null, but that's not valid because we need to go all the way to a leaf node. And so, well, if the left side is not present, we can just return the right side. And if the right side is not present, we just return the left side, because there is no other min, right? And that's pretty much it. Let's run this. Looks good. Let's submit. And that passes, okay? Now, in terms of time complexity, this is going to be O of n, and being the number of nodes. So not too big, it's up to 8,500. In terms of space, it's going to be the depth of the tree, because that's how many recursive calls we will call at a time. So that's how many will be in the stack at a time. So O of n time, and then O of h being the hair of the tree. Yeah, so that's pretty much it for this problem. Thanks for watching, and see you in the next one. Bye.